Right. So this is some of the many groups that have helped us bring technologies into the public, including many U.S. government agencies and companies. There are a few gene therapies that are approved right now, and there are many more in the pipeline. The names don't necessarily matter. I'm very much looking forward to a case study here. CRISPR is the newest kid on the block for gene therapy, and we've been involved in both this editing method, but also ways of delivering gene therapies. We have some new ways of doing that. But I want to tell you mostly about the reading part, the what can be done there. And there, it's like I'm not asking for a handout. I think this is something where we can actually save money, and what's needed is a catalyst where people understand what the opportunities are for getting their genome sequenced, everybody, and completely avoiding certain categories, most categories of genetic diseases preventatively. So this is the path that we like to bring down the costs of things, and one of the ways to bring down the cost of therapies is prevention. So we're also working on bringing down the cost of cures. But here we brought down the cost of genome sequencing from $3 billion for actually a rather poor genome sequence in 2004. Poor in the sense that it wasn't clinical grade. It didn't have your mother's and your father's contributions to your genome separated, and so you really couldn't tell whether you were affected or not. Those first couple of genomes. But since then, the price has come down and the quality has gone way up. So now we've had clinical grade genomes since 2015 for less than $1,000. This includes computer analysis of the entire genome and genetic counseling. So sometimes people say that the interpretation is more expensive than the genome. It is not yet anyway. The cost is actually quite a bit less than that now. It's maybe in the $300 to $400 range, and there's really no reason to cut corners on that, because the return on investment for everybody getting their genome sequenced, or even a large number of people, is about, I estimate, 20 to 1. The cost of not getting your genome sequenced is on the order of $0.5 trillion in the United States alone, and only 4% of births occur in the United States. Now, it's not quite linear because other countries just don't have any option but to let people die. But anyway, 0.5 trillion. Those last two options over there, Nebula has a business model that allows us to have the consumer get a $0 genome, and they do this by recognizing that the payers, the people that currently pay for rare diseases, whether it's orphan drugs or gene therapies or just palliative care or all the care, the parents and family members who lose time away from their job and so forth, that money can be recovered very easily. It's only $300 to sequence the genome. The critical thing, though, is the homomorphic encryption. I'm sorry for that jargon, but what it means is that this has just happened, just feasible, and a lot of people are concerned that their genome can be used against them. They don't want to get their genome sequenced because the government might subpoena it in order to convict their brother, or an insurance company might use it against them rather than for them. I'm talking about a model where they use it for them. But you can now get your genome encrypted from the second that it's sequenced in such a way it can only be used to tell you who you're compatible with. It doesn't even necessarily tell you who you're incompatible with. You don't really want to know that you're a carrier or that you're incompatible with somebody. Not everybody does. I personally have my whole genome. In fact, my whole genome is public information, but I recognize that that's not for everybody. So that we want to develop this extreme version where you can get your genome in an encrypted form. No one can ever read it. It can only be used to identify potential people you can date and fall in love with. That's matchmaking. It's been proven. A version of it that is more stigmatizing and a little less anonymous has been proven in the Ashkenazi community through the Dori Sharim movement since the 1980s. It's more or less eliminated several genetic diseases like Tay-Sachs, very severe Mendelian diseases. And there it is, that's Tay-Sachs and sickle cell. These two diseases had very different outcomes. The Tay-Sachs has been almost completely eliminated in the communities that practice it, while sickle cell, even though it has a very inexpensive carrier testing, mainly used among young athletes, it has not been used in the same way by the community for carrier screening, but could be, as could every disease. The Doria Shearing was started by Rabbi Eckstein in 1983. He had 4 of his first 5 children were affected by Tay-Sachs. It's a devastating disease. I just can't imagine the family burden of having 4 children, and he took it upon himself to bring this organization into existence, and it's been wonderful ever since. This is one estimate. I'm involved in a few economic studies. Really, the cost effectiveness of this is overwhelming, but we want to make sure we dot all the I's and cross all the T's. But this is one public estimate where a lifetime bill of $20 million per patient, and the number of people that could be affected in this way. Even though the diseases are individually rare, they're collectively common. It could be somewhere in the range of 1% to 1 in 12. This is work from Larry Lynn's group. And I am going to cede the remainder of my time to Stan and his colleagues, but I look forward to the Q&A and other components.